Hello and welcome to this video on application performance routing using the IWAN app on APIC-EM. Before we begin, if you have any questions regarding the topology of this discussion, please reference the topology overview video found earlier in this series. So let's level set here really quick. What is application performance routing, or PFR? Well, if I could summarize it in one word, it would be visibility. Think of it this way. Traditionally, routers route traffic based on destination IP prefix information. And no matter how much we tried to build intelligence into the decisions that the router made, ultimately the router made forwarding choices based on very limited visibility and binary metrics. That's where PFR comes in. See, PFR gives the router visibility into the applications that it's routing traffic for. More visibility equals more flexibility to make intelligent decisions. For instance, knowing how to distinguish between Salesforce.com and Microsoft Exchange traffic. Now, not only can we provide preferential treatment, like prefer MPLS for Exchange in this case, but we can also define acceptable service levels and redundancy so that our critical applications will function predictably. All of this visibility is accomplished through two very important components: quality of service markings and application visibility and control. Now, we won't get into the intricacies of each of these components for the sake of brevity, but suffice to say, PFR relies on applications being properly identified via ABC or pre-marked with a DSCP value as they enter the router. This can be done on your LAN switches, an upstream router, or even on ingress into the IWAN border router itself. Once identified, PFR can work its magic, and that's where our story begins today. You'll find the application performance routing components under the Administer Application Policy section within the IWAN app. Here, you'll notice three components that combine to form your policy. Let's take a brief look at each of these sections, beginning with categorization. First, notice on the right side of the screen that IWAN can recognize over 1,300 applications, yet in the middle section of the screen, we're presented with only a subset. The IWAN app intentionally hides some of these applications from view, based on popularity. Hidden applications are known as unpopular. What you see before you, and by default, are applications that are considered popular. Although all applications are enabled on the router, popularity controls whether or not the IWAN app will present them to you for editing. In other words, popularity helps to pare down the list of 1,300 applications to a subset that's more meaningful to your deployment. To make an application popular, first, change the sort dropdown to Application. Then simply click on the gray ribbon to the left of the application name you wish to make popular. Again, it's important to note that an application must be made popular before it can be edited. And speaking of editing, suppose you want to tweak an application to conform to an SLA you've defined in your network. To do this, click the Edit icon to the right of the application name. In the frame that appears to the right, notice the information being displayed. And more importantly, take note of the application's traffic class. This will come up in the next section as we define our policy set. Click the Edit button. Here, notice how we have the option of tuning performance variables that PFR uses to adhere to your network's SLAs. In our case, let's assume that we want to increase the packet loss threshold for a specific application, perhaps because we don't want PFR to reroute this traffic in the event of minor packet loss. Beyond that, you may be asking, what happens if ABC doesn't recognize some of the apps I'm using? The IWAN app can account for this too through its ability to add custom applications. To get started, click the Add Application button in the left center of the screen. On the right side of the screen, enter the name of your custom application. Then choose how ABC will identify this application's traffic. In our case, I'm creating a custom application that is sourced from the IP address 1.2.3.4 and operates on UDP port 2000. Notice, however, that this application can also be identified via its DSCP marking or based on the URL being accessed. My application closely resembles the characteristics of Skinny, so I've opted to use the Similar To dropdown so that the IWAN app can auto-populate the category and performance thresholds for me. Once satisfied, click the Add button. Your custom application can be brought up again by using the search function. Or, alternatively, you can search for your application through the navigation window. Let's assume that I need to recategorize this application. Modifying a category is as easy as dragging and dropping, and as we'll see, Category modification ultimately controls how QoS treats the application. Once we've got our applications correctly categorized, it's time now to define our policy set. Think of this page as defining how traffic will egress the network. And in that vein, notice here on the first screen that there are 3 categories with which to identify application treatment: business relevant, default, and business irrelevant. Application categories defined in the previous section can be placed in each of these buckets according to your business policy by simply dragging and dropping. Anything placed in the relevant category will be remarked according to the traffic class for the corresponding application. You can view an application's associated traffic class by editing the application as discussed in the previous section. During initial setup, you should have chosen a QoS profile that aligns with your service provider. You can view and adjust this profile via the Manage Hub Configuration link from the main IWAN dashboard. In our case, here's how the IWAN app will mark each of our traffic classes. Feel free to pause the video to take an extended look. All application categories placed in the irrelevant bucket will have their traffic marked with a DSCP value of CS1, regardless of their associated traffic class. This is commonly referred to as the scavenger class. If placed in the default bucket, your application will be load balanced across all available links, leaving its original DSCP marking untouched. From there, your service provider QoS profile that you selected during initial setup and that was pushed to your router will dictate the precise order that each of these applications will egress. For instance, voice traffic in the business relevant bucket, having a traffic class of VoIP_telephony, will be marked as DSCP EF and therefore be subjected to the low latency queue of your router's egress QoS policy. Additionally, you may have noticed a drop-down menu on each of these application categories as well. This is where you can define how PFR will further optimize an application. For instance, turning on application performance for a category will instruct PFR to maintain an SLA for that particular application category, i.e., how to handle a violation of that application's jitter or drop thresholds. Selecting no path preference will instruct PFR to load balance traffic across available links. Similarly, selecting path preference will allow you to control precisely which path the traffic should take to keep it within policy. It's important to note that PFR can override your normal routing policy to adhere to the path preference variables you select here. Interestingly, notice on the secondary dropdown that you also have the capability to drop an application that falls out of policy. In some instances, it may be better to discard out-of-policy traffic rather than saturating a different link. So let's review quickly. First, we reviewed how PFR identifies traffic and interacts with QoS. Next, we dove a little bit deeper into application categorization. We learned about popular and unpopular applications, how to edit an existing application, how to modify performance thresholds, how to recategorize an application, and how to create a custom application. Next, we defined the application policy set. We learned about policy categories, relevant, irrelevant, and default, and how to raise or lower priority by recategorizing. Enabling application performance was next on the list, where we reviewed things like path preference and load balancing. If you have any questions about what you've seen today, feel free to reach out to us at iwanapp-pm@cisco.com. Thanks for watching. I'll see you on the next video.